Hello, welcome to chapter 5 of our lecture video discussion. In this video, we are going to introduce you to random variables, and then we'll talk about the two types of random variables and probability distributions used to describe random variables. Now, because in this course we are looking at just the basic level, we are only going to limit ourselves to three probability distributions for describing what we call discrete random variables. Let's start with a quick introduction to what is a random variable. So a random variable basically is any variable that has a numerical description of the outcome of an experiment. What we are looking at basically is any variable that has a numerical value as its outcome. So take for example a variable like age. If I consider a person and I say, what is your age? What I'm going to get as a value for this variable of interest will be numbers. And so that is one very important aspect or characteristic of a random variable. All random variables take numbers. They take numerical values. And so somebody will ask, are random variables therefore quantitative variables? And that is true. All random variables are quantitative variables. And so we say random variables basically are quantitative variables that have values as a result of a random phenomenon. And an experiment is considered to be a random phenomenon. Why? Because we hope to see random values generated after the experiment. And so age is a random variable. Height is a random variable. Weight is a random variable. Number of credit cards is a random variable. Now, can you think of any random variable? I'm pretty sure you could, right? But then the question is favorite subject a random variable? Or your favorite course in class, is that a random variable? And the answer is no. Why? Because it doesn't take numerical values as outcome of an experiment. And so all variables that take numerical values as an outcome of an experiment are considered to be random variables. But when we take random variables, we can generally categorize them into two types. We have discrete random variables and continuous random variables. And so over here we have random variable as the big umbrella, okay? All quantitative variables are random variables. And then we categorize them into two parts. Discrete random variables and continuous random variables. Now somebody will say, what is a discrete random variable? What is a continuous random variable? So discrete random variables basically are quantitative variables that may assume either a finite number of values or an infinite sequence of values. What are we saying here? For discrete random variables, they take finite whole numbers. Any variable whose value is as a result of finite whole numbers are considered to be discrete. The continuous are variables that may assume any numerical value in an interval or a collection of intervals. So one big difference between discrete random variables and continuous random variables is for discrete random variables, we can actually count or we receive their values by counting. And we'll be looking at some examples very soon. For continuous random variables, we obtain their values by measuring. Now let's look at some examples to describe this difference between discrete and continuous. If you take age, you usually, when I ask somebody to give me their age, what they do is they usually give you finite whole numbers, numbers that are whole. The values that we obtain for discrete random variables are values considered to be whole numbers. We don't see any decimal values in them. And that's why we obtain them by counting. Number of credit cards is an example of a discrete random variable. Why? If I ask you to tell me how many credit cards you have, you're actually going to open your wallet and count the number of credit cards you have in there. When I ask you to give me age, you give me whole numbers like 1 year, 2 year, 3 years, 50 years. So those are considered to be discrete random variables. So let's look at some other examples of discrete random variables. Okay, number of cars is an example of a discrete random variable because when I ask you to tell me how many cars you have, is it that you say 0, 1, 2, 3, 4, and so on and so forth? You give me the value of that discrete random variable by counting. Continuous random variables, on the other hand, we obtain their values by measuring. Let's look at some examples of continuous random variables. Height, so age is a discrete random variable, right? And here we are not looking at age in any format, we're looking at age in years. So if we are to limit it in years, you will give me whole number values. Let's talk about height. When I ask somebody to give me their height, somebody will say, I'm 5'6", I'm 6'2", I'm 3'4", right? And so we obtain the height of a person by measuring, and therefore height is considered to be continuous random variable. Why? Because we obtain the values by measuring. The values of continuous random variable may assume any numerical value in an interval of collection. Height is therefore an example of a continuous random variable. What about weight? What do you think? Continuous, and that is correct because we obtain the value by measuring. So let's take a look at some other examples, and I would like you, depending on your field of interest, think of some things that are continuous and some things that are not, that are discrete. So for those in the business, you may, or in the business field, you may think of some examples like how much a person has in their bank account. That is a continuous random variable. How many banks do you transact with? That is a discrete random variable. I've never heard anybody say I deal with 3.5 banks. No, it's either one bank, two banks, three banks, four banks, five banks, right? And so for discrete random variables, their values are whole numbers. Continuous random variables, their values are considered to be floating point values. So note that for the purpose of the midterms. But let's look at some examples and then let's see if we can describe them into discrete and continuous. Family size, the number of dependents reported on your tax return. How many people are dependent on you? Is that discrete or continuous? And it's discrete. Why? Because somebody will say, I have 0 people dependent on me. 1, 2, 3, 4. We obtain the value by counting. What about distance from your home to stores on a highway? Distance in miles from your home to the nearest store is continuous random variable. How many, I'm sorry, do you own a dog or a cat? 1 if no pet, 2 if dogs, 3 if only cat, or 4 if you have both. Because the assignment of the values for the different option here is considered to be whole numbers, that is discrete random variables. And so here we are looking at discrete random variables, and that's what we will be discussing in chapter 5. We are going to limit ourselves to the probability distributions for different forms of discrete random variables. And then when we move to chapter 6, we will spend some time to discuss probability distributions for continuous random variables. But we've already spent time to talk about what discrete random variables. The probability distribution for discrete random variables look at how, or we basically look at a description of how the probabilities of the distributed values are spread. We are spending time to look at how the values are distributed for that discrete random variable. Now we can describe the probability distribution of discrete random variables using what we call tables. And I'm pretty sure most of us are aware for discrete random variables, the probability distributions are done using what we call the frequency distribution table, where we look at the number of values reported for a specific um, unit divided by the total frequency. So let's look at an example here. Let's talk about, first of all, TV sales. How many units of TVs were sold over the years? And so for the different categories of 0, 1, 2, 3, 4, we are looking at the frequency here saying 80 TVs. There were 80 days where no TV was sold, 50 days where one TV was sold, 40 days where two TVs were sold, 10 days where three TVs were sold. So in this example here, our probability distribution for the discrete random variable is going to consider the frequency for the number of days that no TVs were sold divided by the overall total number of days that were considered. And so for 80 days, no TV was sold. We divide that by the total frequency of 200, and that gives us a 0.4. That. And so that's how we determine the probability distribution function for most discrete random variables. We take the value of the frequency or the frequency value or the number of times that value was repeated divided by the total frequency, just like we did in our frequency distribution table. Now, for specific discrete random probabilities, and we can actually, oh, sorry about that, we can actually represent this graphically using different graphical tools to show how the distribution of the different values of that discrete random variable is being displayed. But we are going to spend some time and look deep into the probability distributions of specific discrete random variables. In this course, and I mean there are different types of probability distribution for discrete random variables, but in this course we are going to limit ourselves to discrete uniform probability distributions, which will be the first one we consider. We will spend some time to discuss binomial probabilities, Poisson probability distributions, and hypergeometric probability distributions. And all these are probability distributions used to describe discrete random variables depending on the kind of random variable we are looking at. So we will start with binomial and discrete uniform and binomial in this video, and then we'll pause and go over to the next video where we'll look at Poisson and hypergeometric. But remember, for a random variable, it could be either discrete or continuous. Discrete random variables are the ones we obtain by counting. Continuous random variables are the ones we obtain by measuring. But note that all these are random variables that are considered to be quantitative. And so the values that we obtain from these random variables are numerical values and numerical values only. Now we go down there and we look at the two types, discrete and continuous. And for this video, we are spending much time to look at how the probability distribution function for discrete random variables are done. And so we're going to look at the discrete uniform probability distribution, binomial probability distribution, and then in our next video, we will look at Poisson and hypergeometric probability distribution. Now let's go further and discuss discrete uniform probability distribution. For discrete uniform probability distribution, here we're looking at the kind of probability distribution where for different values of x, we have assigned probabilities to them. And so for the different outcomes of an experiment, we know the chances that these outcomes will occur. Let's take, for example, a young student is going to college for the first time. And for the number of credit cards that she believes the family will give to her, she is assigning a probability of zero point 0.4 that she will have no credit card, a probability of 0.25 that she will have one credit card, a probability of 0.20 that she will have two credit cards, a probability of 0.05 that she will have three credit cards. For uniform discrete probability distributions, what we hope to say is that for the different values of that specific random variable, the addition of their probabilities should always be equal to 1. And so if we already know the probability distribution for these, and we want to know what probability will be assigned to A, the sum of these probabilities should be equal to 1. Therefore, using the complement rule of probabilities, we can know that A will be equal to the sum of these, which is 0.9 plus A equal to 1. Therefore, A will be equal to, using the complement rule, 1 minus 0.9, which is 0.10. And so then the big question is, what is a discrete uniform probability distribution? We are basically looking at the type of random variables where for the different values of that random variable, we have an assigned probability value. And so discrete uniform probability distributions are pretty easy to look at. I want you to look at this example here. Consider the discrete uniform probability distribution below and find the value of Q. And here we are looking at a person who is organizing a party. She has invited people to attend the party. She's assigning a probability of 0.4 that nobody will show up to the party, a probability of 0.2 that one person will show up to the party. Now, two probability values of Q and Q that 2 or 3 people will show up to the party, and a probability of a probability of 0.1 that 4 people will show up to the party. Using the same principle as we did here, can we find the values of Q and Q? And so I want you to spend some time on this and then work on it if you could find the value of Q as a quick practice question. Now, for all discrete random variables and their probability distributions, there are three things we will be calculating. We will be calculating the probability for that probability distribution, the probability of a value occurring in that discrete distribution. We'll be calculating how to find the mean, which is also called the expected value. And we will also calculate how the standard deviation. And so right now we are looking at discrete uniform probability distributions. We've learned how to calculate the probabilities using the table. We are going to look at how to find the mean, and then we'll calculate the standard deviation. And that's how we're going to do it for all of the probability distributions that we're going to look at in chapter 5. We will look at how to find the probability, how to calculate the mean, and how to calculate the standard deviation. Now, the good news is for discrete uniform probability distribution, to find the mean, the formula is to add this multiplication or the product of the value of x and the corresponding probability. And so in all cases, we're going to take the value of x and then we'll multiply it by the probability of that distribution. Let's take a look at an example here. And so let's consider the case where the young college student is assigning probability values to the number of credit cards. For 0 credit card, she is assigning a probability of 0.4. For 1 credit card, she's assigning a probability of 0.25. For 2 credit card is 0.2. For 3 credit cards is 0.05. and then for 4 credit cards is 0.10. The big question here is, how do we find the mean? Now, in previous lessons, we have explained to ourselves that to calculate the mean, we add up the numbers and we divide by the total number of observations. Well, this is a little different. Why? It's different because we are not just dealing with the values of x, we are dealing with the values and their probability distributions. And so it will be incorrect to just add up the numbers and divide by the total number of observations. For discrete uniform probability distributions, we calculate the mean or the expected value by multiplying the values and their corresponding probability values. And so for each of these outcomes, we will multiply the value by the probability just like we did here, plus the next value of x and its corresponding probability, which is that, plus the next value of x and the corresponding probability. And so we are going to do the same for all values of x and their probability distribution and their probability values. And that is how we calculate the probabilities for, we calculate the expected value for discrete uniform probability distribution. Take the value of x times the corresponding probability, which will give you that, plus the next value of x times its corresponding probability, which gives you 0.25, plus the next value of x times its corresponding probability, which is 0.40, plus the next value of x times the corresponding probability to get 0.15, plus the next value of x times the corresponding probability. And when we add them together, it should give us the expected value or the mean of that discrete uniform probability distribution. Now, note very important here that the mean of a discrete uniform probability distribution is not a probability value. So note that mean is not a probability value. What we are looking at here is the average number of credit cards that we can determine based on this distribution here. And so the student can assume that on an average, at least she will make about 1.2 credit cards based on the probability distribution that she assigned to the different number of credit cards she believes will be given to her. So the mean is not a probability value. It's actually just the average number that she hopes to see based on the probability distribution. So as a practice, I have another scenario here for you. I want you to consider the different values of x and their probability distribution to find the expected value. Now, as a hint, know that you need to find the value of k, and once you're able to determine the value of k, you multiply each of these by their corresponding probabilities, add them up together to get the expected value or the mean of the discrete random, discrete uniform probability distribution. Okay, so we've looked at how we calculate the probabilities. We've looked at how we find the expected value. Let's calculate the variance and the standard deviation of a discrete uniform probability distribution. Variance basically is looking at the amount of variability in the values of a random variable. Let's go back here quickly and I'll use this example to explain how we find the variance. So when we consider the distribution for this discrete uniform probability or discrete uniform random value variable, we said they come with values and they assign probabilities. We were able to calculate the average to be 1.20 here. The variance is looking at how these values of x vary from the 1.2 average, considering the effect of the probability that these values will occur. And so remember, the variance is basically a summary of how the values differ from the mean, considering the effect of their probability of occurrence. What is the formula for finding the variance of a discrete uniform probability distribution? The formula says take the value of x, subtract the mean from it, square your answer, and multiply by the corresponding probability. And so once we're able to do that, what we are looking at is we are able to calculate the weighted average of the square deviation, how the values deviate from the mean itself while considering the weight of their probabilities. And then of course, once we're able to calculate the variance, we will square root the variance, and that will give us our standard deviation, right? Remember, your standard deviation is equal to the square root of the variance. And so let's go into it using an example to calculate how we could find the variance of a discrete uniform probability distribution. Let's take, for example, in the same instance, the college student who is thinking of how many credit cards she will be given. So for 0, the probability assignment is 0.4, 1 has a probability of 0.25, 2 has a probability of 0.2, 3 has a probability of 0.05, 4 has a probability of 0.4. Remember, in our previous example, we were able to calculate the average, and we said the average number of credit cards is 1.2. Having that in mind, how do we calculate the variance? Remember, our formula says the variance is equal to the sum of the difference between x and the mean, all squared, times the probability of x. So what we're going to do here is we are going to take the value of x. In the first case, the value of x is 0. We will subtract 0 from 1.2, which is the mean. 0 minus 1.2 will give us negative 1.2. We will square it, and that will take care of the negative difference. And so negative 1.2 squared will give us 1.44. We will multiply this 1.44 by the assigned probability for 0, which is 0.4, and that will give us 0.576. Let's look at the next value of x, which is 1 with a probability of 0.25. Remember, our mean is 1.2. So step 1, we will subtract the 1.2 from 1, so it will be 1 minus 1.2. That will give us negative 0.2. We will square it. We square the negative 0.02. That will give us 0.04. We will multiply 0.04 by the value of the probability, which is 0.25, and that will give us 0.010. So we will do the same thing for all the values of x and their assigned probabilities. And the total, remember, that's why we have the summation here. It means once you find everything here, add them all up together. The total, which will be our variance, will be 1.660. And then, of course, when we square root our variance, it will give us our standard deviation, which is 1.2884. I want you to spend some time on this and calculate the variance for this example here. So here we have another example. I want you to spend some time on it and calculate the variance and standard deviation for that. The next random variable that we will be looking at is binomial probabilities. Why? Because binomial probabilities is also considered to be an example of a probability distribution that is considered to be discrete. With binomial probability distribution, we are looking at the kind of cases where there are only two outcomes. And so let's say we perform an experiment, and the experiment consists of a number of sequence of n identical trials. If the random variable of interest only has two outcomes, that presents a binomial distribution. Let's look at examples of instances where we could consider binomial distribution. Do you have a car? Yes or no? Because the outcomes are yes or no, that is a binomial distribution. With binomial distribution, our interest is the number of times success occurs. And so somebody will say, oh, if it's just one trial, is that not categorical instead of quantitative? But that is not what our interest is in. Our interest is how many people said yes, how many people said no. And so let's say I take 10 individuals in a class or 10 students in a class, and I ask them the same question: do you have a car? And out of the 10 individuals, the number of yeses is 6, the number of no is 4. Now, because the number of success here was received by counting those who said yes, and the number of no here was received by counting those who said no, this kind of distribution presents itself not as a qualitative variable, but more as a quantitative variable. And because it's now a quantitative variable, we can look at whether it is discrete or continuous. And the big question here is, how do we receive the numbers? We receive the number by counting the number of those who said yes to the question. And because the number of those who said yes to the question was an actually countable value, it becomes a discrete binomial, a discrete probability distribution under the discrete random variable description. And so binomial probability distribution is used to describe discrete random variables. Now, let's just like we did in the first case, we are going to look at three things. The three things we are going to look at is, how do we calculate the probability? How do we calculate the mean or the expected value? And how do we calculate the variance and standard deviation? So let's start off with the first instance where we calculate the probability. There are two ways we can actually calculate probability for binomial distribution. First, we either use the formula, which is this formula here called the binomial probability formula. Or another way is to use the table. You decide which of these two is your favorite approach, either to use the table or to use the formulas. It all depends on you as a student. But let's first of all look at how we can calculate binomial probabilities using the formula. The formula says take your number of trials, factorial divided by the number of success x into bracket n minus x, or factorial, times the probability of success in just one trial to the power of x times 1 minus the probability of success for one trial to the power of n minus x. And so I'm pretty sure you are a little confused here. What is n? What is x? What is p? These are the three most important values that you need to calculate the probability distribution for binomial distributions. N is the number of trials, the number of times the experiment was performed. How many experiments did we consider? And so if we are asking people, do you have a car? Yes or no, the N here refers to the number of participants. How many people were asked the same question? In our previous example where I said I asked 10 people, N here represents the total number of individuals who responded to the test or to the experiment. X here represent the number of success. And so X is the number of success. How many people said yes, they have a car? And so if I define X as yes as success, then my X here represent the 6 individuals who said yes, we have a car. And then P here represent, for each instance, what is the probability that somebody will say, I have a car or I don't have a car. Now, for a certain kind of binomial probability distributions, the probability of success may be a little different. Let's say if I'm tossing a coin, it's a 50-50 chance that I'll get a head or a tail. And so that is binomial, but the probability of success for one trial is 50-50, right? But in some other cases, the probability of success may be a little higher than others. For example, if the question was, do you drink water every day? The probability of somebody saying, yes, I drink water every day is a little higher than the probability of somebody saying, no, I don't drink water a day. And so the probability of success for a single trial is mostly subjective for different trials. But in the case of our example here, let me assign a probability of 0.5, which is a 50-50% chance that somebody will say, yes, I have a car. And so P here is the probability of success, the chance that somebody will say, yes, I have a car. So knowing this, we can go ahead and calculate using the formula. Um, Again, note that the formula can be divided into two main parts. One part here is the number of experimental outcome providing exactly X success in N trials. And this part here is the probability that a particular sequence of trials with X number of success will result in success. And so all I gotta do is put in these values here. Again, 10 factorial, my n factorial will be 10 factorial divided by x, which is 6 factorial, into bracket 10 minus 6 all factorial times p, which is 0.5 to the power of x, which is 6, multiplied by the bracket of 1 minus p, which is the probability of success in a single trial, 0.5 to the power of 10 minus 6. And so we solve this part here, which is a combinatorial function. We solve this part here, which is giving us the probability of success. And we solve this part here, which gives us the probability of failure. Now, for the sake of time, I will not do this, but we'll discuss it in class. So if I go ahead and I perform my calculation, the value that I will get is the probability of success for the entire binomial distribution function. Let's take a look at an example of how that is done here, and then we will take a break. So Evans Electronics is concerned about low retention rate for its employees. In recent years, management has seen a turnover of 10% of the hourly employees annually. Thus, for any employee chosen at random, management estimates a probability of 0.1. Okay, so now we have our first value here. The probability of success, which is turnover, is 0.1. A probability of 0.1 that a person will not be with the company next year. Choosing 3 hourly employees at random. What is the total number of participants that was taken in this experiment? N equal to what? 3 hourly employees at random. What is the probability that one of them, so our one here, represent the number of success X, which is equal to 1. One of them will leave the company this year. Quick tip, for all binomial probability distributions, we always give you the three numbers in the question. The number of participants, the probability of success for each participant, and the number of success. In this example here, we have 3 individuals that were chosen at random. The chance that they will leave the company next year, one of them will leave the company next year. Chance that a person will leave the company next year for the entire company is 0.1. And the question is, what is the probability that out of the 3 individuals, one of them will leave the company? We can use the probability distribution function for this binomial distribution. And what is the formula? It says n factorial divided by x factorial to bracket n minus x all factorial times p to the power of x times 1 minus p to the power of n minus x. And so we will solve this part here. we will solve this part here, we will solve this part here, and multiply all three together. Let's look at how we will do that using the binomial probability function, just like we have here. And so we take our value of n, which is 3 factorial, divided by the value of x, which is 1 factorial, into bracket 3 minus 1, or factorial, times p to the power of x, which is 0.1. Remember, p is 0.1. 0.1 to the power of x, which is 1, times 1 minus p. 1 minus 0.1 will give us 0.9. So we take 1 minus p, which is 0.9, to the power of n minus x, and n minus x is 3 minus 1, and that will be equal to 2. So when we solve this, we get 0.243. Another way, which is a much easier approach, is to use what we call the binomial distribution table. And so you can either use the binomial probability function, which is one approach, or you can use approach 2, which is the binomial probability distribution table. How do you use the binomial probability distribution table? You go to the binomial probability tables right here. And a copy of this table has already been uploaded on Moodle. You can check that. Now you go to the binomial probability table and you go there with these three values. Your value of p, which is 0.1, your value of n, which is 3, and your value of x, which is 1. Let's take a quick look at how we will do that. So on this table, which will look something similar to this, or you can just Google and you will see the table on Google. But a copy of the table has already been uploaded on Moodle. Now on the table, you first locate a value of n, which is 3. Okay, so don't forget, we have n equal to 3, p equal to 0.1, x equal to 1. We locate the value of n, which is 3. We look up the value of x under n, and so for the 3, we have the values of x equal to 0, 1, 2, 3. Now somebody will say, why did we end at 3? We can't go more than the number of participants, right? So the number of success for 3 will always be the last value there. Okay, so we look at the value of x, and our x here is equal to 1, which is right there. And what we're going to do is we're going to match it up with the p values here, the probability of success for single trials. In this case is 0.1, so we look up 0.1 here. So where these three values intersect, which is right here, that will be our probability of success for one person in a total of 3 participants. And so just like we calculated for the table here and got 0.243, we do the same thing here and we get 0.243. When we get a chance to meet online, we are going to look at this practice question here and discuss how to find the probability for a binomial distribution using the tables and also using the binomial probability formula. Okay, I'm going to pause here and then we'll continue from the next video.